Hi guys, this is Vineet and I welcome you to this video. Today's video topic is numeric data types in SQL Server, and this is part 1 of the video series. Guys, if you haven't yet subscribed to my channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos. So let me give you 5 seconds. Please go ahead and subscribe right away. So guys, I hope you must have subscribed by now, so we can proceed ahead. So let me take you to my notes quickly. So today we will discuss upon numeric data types. So let's begin. So SQL Server supports the following numeric types. The first one is the bit type, and then we have decimal and numeric, which are one and the same thing. They are synonyms. Both can be used interchangeably. And another numeric type we have is float and real. And then we have int, big int, small int and tiny int. Lastly we have money and small money. These all come under the numeric data types. Now let's start our discussion with the bit data type, which is the first numeric type. So if we talk about the bit data type, it's an integer data type that can take a value of 1, 0 or null. Now if we talk about SQL Server database engine, it optimizes the storage of bit columns. So any columns declared with the bit data type, SQL Server optimizes the storage of data. Now if a particular column holds 8-bit in data value, then the columns are stored as 1 byte, whereas if they are from 9 up to 16-bit columns, then columns are stored as 2 bytes and so on. Now the bit data type can be used to store the boolean values, which can be 0 or 1, and the string values true and false can be converted into bit values. So basically true is converted into 1 and the false is converted into 0. And converting to bit promotes any non-zero value to 1. That's another thing. And the bit data type supports the count function. So the bit data type can be used with the count aggregate function. However, this particular data type, the bit data type, cannot be used with the aggregation functions like sum, average, min and max, as they don't directly support the bit data type. So we cannot use the bit data type with these aggregate functions. Now let's come down to the decimal and numeric data types, which are again numeric data types. So these both are numeric data types, and if we talk about the decimal and numeric, these are numeric data types that have a fixed precision and a scale. We will talk about the precision and the scale soon. Now if we talk about the decimal and numeric, these are basically synonyms and can be used interchangeably. And if we show you the syntax for this, so both have the same syntax, and the first one starts with the decimal keyword, and along with the bracket that defines the precision and scale of the number or the constant. And another one is numeric. It uses the same notation. P stands for precision here and S stands for scale, and we will define that shortly. Now the fixed precision and scale numbers, when maximum precision is used, valid values are from minus 10 raised to the power 38 plus 1 through 10 raised to the power 38 minus 1. So this is the data range supported by the decimal and numeric data types. Now let's talk a little bit about the precision, what the precision is. The maximum total number of decimal digits to be stored is called the precision. So whatever the total number of digits that are stored in a particular variable or a column is known as the precision. Now this number includes both the left and right side of the decimal point. So whatever digits are there on the left hand side of the decimal point and whatever digits are there on the right hand side of the decimal point, if we add both of them, we come to precision. That's the precision. Now the precision must be a value from 1 through the maximum precision of 38. So these data types, decimal and numeric, supports the maximum precision of 38 digits, and if we don't specify any precision, default precision it takes is 18 digits. Now let's talk about the scale. Scale basically refers to the number of decimal digits that are stored to the right of the decimal point. So any digit stored beyond the decimal point over on the right hand side, this is known as the scale. Now if you subtract scale from a precision, this will give you the maximum number of digits to the left of the decimal point. So this is what is mentioned here. The scale number is subtracted from the precision to determine the maximum number of digits to the left of the decimal point. And scale must be a value from 0 through p. So scale can range between 0 and p as denoted by this equation, and can be specified if precision is specified. The default scale is 0, and so if we talk about scale, it can be greater than equal to 0 denoted by this part, or it can be less than equal to p. So scale ranges between 0 and p. Now the maximum storage sizes for decimal and numeric data type varies based on the precision we are taking. So if we take 1 to 9 precision or 98 precision, it requires 5 storage bytes. If we take 10 to 98 precision, it requires 9 storage bytes. If we take 20 to 28 digits, it requires 13 storage bytes. And if we taking a precision of 29 to 38 digits, it requires 17 storage bytes. Now let's talk about conversion of decimal and numeric data. And if we talk about decimal and numeric data types, SQL Server considers each combination of precision and scale as a different data type. If we take an example, decimal 55 and decimal 50 are considered different data types. Now in T-SQL statements, a constant, we will talk about constants later, which is basically a fixed value. A fixed value with the decimal point is automatically converted to a numeric data value. So whenever inside of any T-SQL statement, if we are using any constant that has a decimal point inside it, that value automatically gets converted into the numeric data value. That is what it is saying, and using the minimum precision and scale necessary. So if there is some conversion with a constant which has a decimal point in it into a numeric value, if we are doing any such kind of conversion, so that conversion uses the if we talk about the implicit conversion, that uses the minimum precision and scale, right? And let's take an example for this. So for example, if we take a constant, so this is a constant value 12.345. When it is converted into a numeric value, if we try to convert this particular value into a numeric value with a precision of 5 and a scale of 3, this is talking about the conversion. So if we try to convert the value 12.345, which is a constant, into a numeric value, it will take a precision of 5 because there are 5 digits, and it will take a scale of 3 because there are 3 digits to the right hand side of the decimal. Now let's talk a little bit about the conversion from and conversion to and type of possible risks. So if we try to convert the decimal and numeric values to a float or real value, there could be a possibility of loss of precision. And if we talk about int, small int, tiny int, float, real money or small money, if we try to convert these data types into decimal and numeric, there could be a chances of possible overflow. Now by default, SQL Server uses rounding when converting a number to a decimal or numeric value with a lower precision and scale. So whenever we convert a number to a lower precision or scale, we lose on precision, and basically there is a rounding of occurs to fit that number within the lower precision and scale. Conversely, if we set this option to on, there's an option inside SQL Server, set arith abort. If this option is set to on, SQL Server raises an error in the cases of overflows. So sometimes overflow also occurs, like if you take a look at this table, if you try to convert these data types into decimal and numeric, sometimes there are chances of possible overflow. So if this set arith abort option is turned to on, if there is a case for overflow, it will raise an error. And loss of precision and scale is not sufficient to raise any errors. And if we talk prior to SQL Server 2016, conversion of float values to decimal or numeric is restricted to the precision of 7 digits only. Any float value less than 5e minus 18, which is the exponential notation, which stands to 5 into 10 raised to minus 18. When set using either the scientific notation of 5e minus 18 or the decimal notation of this, rounds down to 0. This is what we are talking about before SQL Server 2016. So when we try to convert the float values into numeric or decimal or numeric, the values are restricted to 17 digits only. Let me go through this paragraph once again to give you a better clarity. So before SQL Server 2016, if we try to convert the float values into decimal or numeric, it is restricted to values of precision of 7 digits only. So any float value less than 5e minus 8 or this value rounds down to 0. And this restriction doesn't appear in SQL Server 2016 and later version. So if there is any value less than this number, it automatically rounds down to 0 if we are using the version, any version before 2016. And this restriction does not appear in SQL Server 2016 and later versions. Now let me take you through a demo of creating a table using the decimal and numerical data types. So let's trigger SQL Server quickly. I've just launched it and we'll go through a practical here. So SQL Server will launch soon, waiting for it to get launched. Yeah, it's triggered over here. Okay, it's launched in the background. Let me try to connect to it. Let's try to connect to a default instance of SQL Server and trigger a query against the AdventureWorks 2022 database. If you haven't installed this database, you can watch out one of my videos. You can check it out on my channel page, and you will find a video on how to install the AdventureWorks database. Now, you can also trigger this query against any of the system databases as well. It's not essential to use AdventureWorks for this this particular practical. So I can also trigger a same query against the master database quickly, like this. And yeah, it is using the master database. Let's create a table. So we have to create a table, and let's name this as my table, and let's define the table structure over here. Now let's take the first column. So this time I'm taking a my decimal column as the first column and taking it as decimal type with the precision of 5 and 2. And let's define another column which is my numerical column, my numeric column, I can say my numeric column. Let's take it as numeric type with the precision of 10 and 5, right? So in this there will be 5 total digits, and in this precision there will be 10 total digits. The digits to the right hand side of decimal will be 2, and in this case the digit to the right hand side of decimal will be 5. So here the table structure is defined. Now let's mark this as the first batch to go. Now in the second batch, let's write in some insert statement, and let's try to insert into my table, and let's try to insert the values in the first column, which is the of decimal type, which is my decimal column. Let's put 1 2 3, and for second column let me put 1 2 3 4 5 dot 1 2 as the value for the second parameter, which is my numeric column. Now after that I can put in go, and let's print the values for these columns. Let's print these columns after the insertion of values, and also separate this statement by semicolon. So let's select these columns from dbo.myTable, and at the end what we will do, we will drop the table dbo.myTable. I will drop that. So I need to use the drop table statement to be specific. Let's execute these statements first. I'm not dropping the table yet. Let's see how the values, these values or constants get converted into decimal 5.2 and numeric 10.5. So let's execute this part of the statements, and we see the values, final values here. So 1 2 3 got converted into 5.2, which is total of 5 digits. Here we have 5, 1 2 3 4 5, and dates after decimal are 2. So .00 is appended to 1 2 3 over here in order to make compatible to this data type. Now let's talk about second value. It has 7 digits, 2 digits to the right hand side of the decimal. So here we want to convert this value into 10 digits. So dates can be added on the right hand side only. So 10 digits are required, and 5 digits of precision to the right hand side of decimal. So here we have 5 digits to the left hand side of the decimal. We can add 3 zeros to the right hand side of the decimal after 1 2 to make it compatible with this data type. So that is how it is changed. 1 2 3 4 5 dot 1 2 and 3 zeros were appended. Now it is in the numeric 10.5 form. So I hope you like this practical, guys. If you really like this practical, please click on the like button, and I'm wrapping up my video here, guys. And in my next video, what I will do, I will discuss on the float and real data types, and there's a lot much to cover. and I will show you some practicals as well. So stay in tune. If you have not yet subscribed to my channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future and upcoming videos. And do post in your comments, guys, and share my video with your friends. And guys, if in case you want to contribute to this channel or make donations to this channel, you can do so via two ways. There's a topmate.io link given at the bottom of this slide. You need to type this link as is on the address bar of your browser, either Google Chrome or Microsoft Edge. And once this page gets open, you can make your donations via there. And in case you want to make donations via any of the UPI apps like Google Pay or Phone Pay, you can do that so as well. So on the right hand side, I have shared my Google Pay UPI code, which you can scan via the Google Pay app or Phone Pay app to make any donations or contributions to our channel. So guys, I hope you like this video today, and I thank you so much for watching this video today. In case you want to write back to me, you can write back to me on my email address vrmavane@gmail.com. I thank you so much for your time on this video today, and you have a wonderful day ahead. Thank you.